so Matt's going to open us up, and then living the PJ work day. I kind of live in leggings. I do. I put on a nice shirt for you guys today, but yeah, Matt's going to bring us through a couple slides, and then as promised, we are going to go through the code for Matt's new correlation funnel package. We're going to look at and interpret and look at the code for a decision tree. We're going to do some XGBoost and talk about the data that I'm working with, and it's all going to be fun and exciting. And then at the end, we will be, making sure that you get all these materials as well. So the slides, the code, the data set, everything that you need to run this analysis on your own, you will have.
Cool. Well, thanks so much, Kristen. And this is the second time that we're getting the opportunity to work together. So I'm really excited about this. Thank you so much for having me back. And
one of my favorites, Matt.
Thank you so much. Yeah, no, this is like one of those webinars, one of these events where it's like, it doesn't feel like work. It just feels like a conversation, right? I know that's how I feel, at least.
Oh, sorry. I was reading the Q&A.
Oh, no worries. I just said it feels like a conversation, and then there was like dead silence on the other end. So
when I'm in the zone, I'm in the zone.
So, the thing that we want to talk with you guys about today is machine learning NR. And Kristen has this really cool analysis that she put a lot of work into with her survey data. So that's going to be like pretty much what we spend the bulk of our time on today. It's going to be really neat though, because you're going to be using a new R package. It's called Parsnip. And if you're familiar with Python, it's kind of like scikit-learn for Python. And it's developed by a gentleman at our studio. They have a team that's working on it. And it's just a really well done package. It just makes machine learning in R so easy. So Kristen, you may not know me. I'm Matt Dancho. I'm the founder of Business Science. And I'm teaming up with Kristen at Data Moves Me today. So we're excited to kick this off. And Kristen, I don't know if there's any words that you want to say.
No, just excited to be here and excited to get into the code.
Sweet. Yeah, me too. Just a quick agenda for today. So I'm going to kick things off. I'm going to talk just a little bit about some high-level things like what is machine learning, why is it important to the business, and then in the second piece, that's where we're going to spend the bulk of our time. We're going to be working with machine learning. It's a case study. And it's actual data that came from, and I believe it's the Data Moves Me survey that you did, Kristen. Is that correct?
Yes, it is.
Okay, and that comes out of SurveyMonkey, which is a popular platform for doing surveys, and it does the data that, I'm not sure if you scraped it or if you have a download like a CSV or something like that, but it comes in. It's not very tidy. It takes a little bit to work with.
Not tidy at all.
Yeah.
So yes, it is a CSV. So and this I think is a really good example of something that people can do themselves, because I'm always getting questions, how do I create a project for my portfolio? And the truth is, you can create a survey on SurveyMonkey. You can promote that survey and have people share it for you. And then in the end, you can download the data as a CSV. Now, it does come, basically there's one column for each possible response, right? It's not aggregated by question. So that's where the tidyverse and dplyr really come into play, that allow you to reshape your data from wide to long. And I have a blog article that I wrote where I actually just shared my code. This is me taking my SurveyMonkey output and reshaping it so that I can do machine learning on it. And so sorry for that long-winded response. You can continue, Matt.
No, that's perfect, because I want people to understand that, like, the data that you get, you're going to have to process it, and this is a real analysis, and it's an end-to-end analysis, which is nice because it shows you the full kind of process. We'll talk a little bit about that in a minute. And then I'm going to wrap things up then. So Kristen's going to do the heavy lifting with the coding, and I'll help out where needed. And then at the end, what we're going to do is we're going to talk about machine learning, and we're going to give you some secret tactics, some pro tips, and some recommendations to help you kind of get through some of the issues that my students and the people that I work with constantly run into. And so we're going to go over some pro tips there and really help you out. So with that said, why learn machine learning and why implement it in a business? Well, it turns out that machine learning, it solves high impact problems. So it doesn't matter what part of the organization you belong to, if you're in sales, finance, accounting, marketing, HR, they all have their own set of problems that are very commonly handled now with machine learning. And these are great candidates because they're what's called high impact. When I say high impact, that means they have a large dollar value assigned to them. So either they're driving up costs or there's more potential revenue to generate if you implement machine learning and prediction into your processes. So some of the examples of problems that are very commonly handled, we've got customer churn, which is a big one on the sales end. That can save companies millions and millions of dollars if you can figure out which customers are going to churn and leave the company, and if you can contact them and implement preventative strategies to retain them longer, especially for subscription-based companies. That's a big one. For finance, you've got fraud detection, you've got credit default risk and risk of loan delinquency. So these are common areas where you can use machine learning to determine whether or not somebody is going to leave or is going to default on a loan, or if there's anomalies in there, that could be an indication of fraud. So that's something that you can use machine learning for. HR, and this is a problem that I'm very familiar with because I've actually worked with companies on it. Employee attrition. It's basically the same thing as customer churn, except it's the employees that are leaving the company. So you want to try and predict which employees are at risk of leaving and try and implement preventative strategies for the high performers, the ones that you cannot lose. Your company cannot afford to lose. And then you got marketing and accounting, and you've got all sorts of things there. So there's a lot of these high impact problems that can save your company millions of dollars. So that's why we want to learn machine learning. One of the most important concepts to learn is one that we're going to talk about today, and this is one that Kristen's actually going to go through with her SurveyMonkey data, is binary classification. And that's just a simple 1 or 0. Is somebody likely to leave the company, a customer churn, if it's a customer churn problem? Yes or no. Is an employee going to leave the company? Yes or no. And Kristen, what is the problem that we're handling today that is you've identified people that are likely to leave the company based?
So this is people actually who have left in the past. So just for a little context about the survey, you probably saw it on social media going around. I created a survey for a book that Kate Strachny and I are writing together. It's called Mothers of Data Science, where we interviewed Kathy O'Neill and some really fantastic women in data, and then launched this survey, Parents of Data Science, where we wanted to get at some demographics. How much are you making? How long have you been in the field? Your gender, your age, all sorts of stuff. And then what I really wanted to get at, was what type of parental leave did you have when you had a child? Do you feel comfortable asking for leave if you need to go to your child's something at their school? Mm-hmm. Do you feel comfortable voicing those needs? Have you ever felt difficulty, voicing your needs to or desires to go to a conference or travel for work? And then one of the questions was, have you ever changed jobs to pursue better work-life balance? And so there are people who change jobs, and what we found through doing this analysis was that, it's more the people who are having difficulty voicing their needs. They don't feel supported. Those are the people who are more likely to move. So some of the other Things I asked were also, are you remote? Do you work in an office? Do you ever feel like you were unfairly treated as a, due to being a parent and having to juggle being a parent and work? And then, do you feel like your partner contributes 50-50, whether it was the man taking the survey or the woman taking the survey? Hey, do you feel like your partner contributes, less than you, more than you, or the same in terms of, baby rearing activities?
Right. Yeah. And this analysis is great because it's the exact type of analysis. And this is just a survey that you ran. So this could be very valuable if you ran this, say, internally inside a company and you had anonymous data where you're able to kind of understand, what are the attributes that people are feeling, and are people generally kind of predisposed to leaving the company, or if they've left a company in the past, what has contributed to that. So this is the type of analysis that's really lends itself well to saving a company money, from what I saw of it, at least. So thanks, Kristen. Yeah, no, that's great. And binary classification, that's what we're going to be talking about today. It's one of the tools that'll save your company the most money. And then for those that are unfamiliar with machine learning, if this is the first time that you're kind of being exposed to it, it does get a little bit, we'll say machine learning kind of gets a reputation of being highly complex, but it's really what it boils down to is kind of a framework for analyzing a few different types of problems. So what we have here in this diagram is machine learning is kind of at the top, and then this kind of breaks it down into into different types of machine learning. So the one that we're going to be focusing on today is this branch called classification, and this is just trying to determine whether or not something's going to happen. So binary classification is 1, 0, yes or no. There's only two different classes that are possible. One is yes, one is no, one is true, false. And customer churn is an example of that, or employee churn, or employee attrition. And then, so there's supervised and unsupervised. Supervised means that there's actually a labeled data set. So Kristen, you have data where you have kind of an outcome, and then you've got all of these different questions that you asked. So the outcome is whether or not that person has ever left the company in the past, yes or no. And then all of the different features are going to be the other questions that were involved in the survey. Does their partner contribute a lot, yes or no? Have they ever felt like they were unfairly treated, yes or no? And those types of things. So we can actually use that data to develop a predictive model. And that's what we're going to show you how to do today. So it's going to be classification. There's also regression, which is just kind of like, it's very similar to classification, except we're predicting a numeric value. And then there's a branch called unsupervised learning, which is an example of that would be clustering. So that would be like customer segmentation. If we're trying to figure out different segments in our customer base, and we don't know, how many segments might be in there, we just have to kind of run an algorithm to figure out which customers are similar to each other and then kind of separate them out. So classification is what we're going to be focused on, and that is machine learning in a nutshell. So real quick on the process that we're going to do today. So we're going to come through a full end-to-end analysis, which is great. I love doing these. These are the best teaching tools. And what we're going to do is we're going to start here, and we're going to basically use a couple of different packages, which are different programs that we've installed from R. So two of them that are very popular, dplyr and ggplot2. That's going to be used for manipulating data and also visualizing data. And then we're going to be doing some pre-processing, which is with a package called recipes. And then at the end of it, what we're going to be doing is machine learning to actually build predictive models. We aren't going to use H2O and Lime, but I'm just throwing these in here so you see these ones. These are these tools are very high end. I actually use them when I consult, and I'll talk a little bit about those at the end when we get into the pro tips. But we're going to be focusing on this package called Parsnip, which is like scikit-learn, but for R. So that's the machine learning piece. Okay. All right, Kristen, are you ready to go?
Oh, I'm ready.
All right. Well, I'm going to let you take it over. Here, just hold on one second. Let me escape out of this, and I will stop sharing. So now you can share.
All righty. Awesome. Thank you so much, Matt. All right. Everybody see my screen?
I see
it. Yep. So this is here for, I've already installed this, but I'm assuming most of you have not because it's brand spanking new, but this is a package that Matt had just created, a correlation funnel. And so we'll be taking a look at this. And so here's the packages that we need to call. And so in addition to the ones that Matt had just been mentioning in his slide, we also have our sample, right? Because we need to take a random sample from the data and partition our data set into a testing set and a training set. We'll talk more about recipes because I absolutely love it. Yardstick allows us to get an ROC AUC curve, right? And so if you've never heard that term before, it's basically saying how much better is your model at classifying than flipping a coin, right? So it's a nice picture that we can get to understand how well we're able to predict with our data. XGBoost, we're going to be going through that. This package right here, the CK means, is creating the feature importance plot that you probably saw going around social media last week while I was promoting this webinar. Our part allows us to get the cart decision tree, and then our part.plot allows us to get a really pretty picture of that decision tree that we've created. Okay, so I'm going to call my libraries, our sample. And it's not a demo if something doesn't go wrong. So it looks like it's here and it just didn't.
Sure. Looks like
digest. There's no package called digest. I wonder if I try and install it. This probably isn't going to work.
Do you already have it installed or no? Oh,
it says it's not. Yeah, and I don't see it there, so we'll just try and install digest real quick.
Yeah, this is always fun. This is what's so nice about the live is you get to see the problems that we actually handle on a day-to-day basis. You know, because this is the stuff that we run into all the time. As if, yeah, it looks like it was installed there.
Yeah, yeah. No, this is real life, guys. Hashtag real life. Okay, wonderful. So now we've got all our libraries that we need, and oh. No, we don't, because I haven't run the correlation funnel. And then Tidyverse, which is going to install a whole host of packages that allow us to easily manipulate data. Okay, so I will be reading my data in. And so, like I said, this is the survey data. I had written a blog where I show how I transformed my data from the binary variables that I get as output from SurveyMonkey to a data set that I can use for machine learning. So if you're interested in that code, you can go check out the blog article. This is the data set already in the long format, right? So I've already done some of the data manipulation. But so I'm using read CSV to call that in. And then, of course, after we call in data, we take a look at it. And so I've already talked about a lot of these, but
Hey, just real quick, Kristen, sorry didn't mean to cut you off.
No, I know, and I start going really fast sometimes.
No, you're doing great. You're doing great. One of the panelists wanted to see if you could maybe drag to the right the middle pane, so that way we can see the code a little bit more. Yeah, there,
Sure.
perfect.
Okay, and so this is the data that I've put in the long format. We have an ID column, which of course that's just, there's a number for each row, and so we're not going to want to use that in machine learning, so we'll go through the process of removing that. The status is just whether or not the person completed the survey. And then we have the things I was talking about, the gender, their current role, whether they're in management or data worker is data scientist, data analyst, data engineer, any of the data professions, hands-on data person, or somebody who's looking to get into the field, whether or not you have kids actually in the home. And that is a qualifier for the analysis, right? So there were people who took the survey who do not have kids actively living in the home with them during some portion of the work week. But what I really wanted to get at is people who are juggling having kids and working. So I make sure that this is set to kids in home, yes. Another call out that I want to make while we're going through this is that there is probably a fair amount of bias in this data, right? So I've been a data scientist for 10 years. I have a lot of friends on LinkedIn who are also pretty well established in the profession. So, you know, when I'm posting a survey and I'm asking my friends to post a survey who have also been around for a while, you know, it may be that, you know, we're going to skew a little bit heavier in a longer term career than is actually the truth of the market, right? But this is the data that we have. But I just want to call out that there could be a fair amount, or there probably is a fair amount of bias here. Okay, so we had called the data in to survey data tibble. And so now we're going to take survey data tibble and we're going to remove the ID column because we know we're not able to use that. Binarize is specific to the correlation funnel package that Matt created. And so that bins numeric data and it hot encodes categorical variables. And then it goes on to use Pearson's correlation. And then after that, it's going to create a pretty plot for us. So I'm going to just pull this over so that we can run this and see the plot. And there's our plot, right? And so this looks like a funnel in the sense that the variables at the top are they're closer to the bounds -1 and 1, and so there's, you know, we're seeing more correlation there. And then as we get variables that have less of a correlation to speak to, they're at the bottom of the funnel, which is sort of nice because now we have a priority order of what is the most correlated.
Yeah, and this I found is a great exploratory data analysis tool. I actually teach it in my university, but also it's great for, you know, understanding and making sure that you've got good features before you move on to the more labor intensive machine learning part, you know, doing all the parameter tuning and this and that. Because like the last thing you want to do is spend, you know, hours and hours developing these machine learning models when you don't have good data to begin with. So this is really kind of kills two birds with one stone. You understand your data a little bit better. You see probably what's going to be the most important features, and like Kristen said, they go right to the top and form kind of a funnel. And then you also make sure that you've got some correlation in there and some feature importance. Otherwise, you probably won't get that great of a machine learning model, and you may need to go back and get some better data or think about your experiment a little bit better and figure out how you can get some good data.
Yeah, no, and especially when let's say you're building a retention model or something, and there's 5,000 potential variables that you could use. And typically retention models are measures of tenure and engagement, but depending on what it is you're doing, you may have hot and coded a number of binary variables, and your data set can get large quite quickly. There could be different ways that are measured by the company that a customer is able to, quote, engage, right? And so one of the first things that I would look at, typically, I look at a list of, an ordered list of correlations if I'm going to build something like a logistic regression model. But it's really nice to have it as a visual, right? Because the number doesn't necessarily matter. We know that if, the correlation is below like 0.08 or 0.09, there's really no correlation, and then there's more correlation as we get higher or more negative, right? So this is really handy. And just to call out in the code too, so we're correlating, did you change company? Yes or no, right? Or did you change company? Yes, changed company. And so we see that yes is at 1 because it's perfectly correlated with itself. Everything is always going to be perfectly correlated with itself. And no is negatively correlated with, because obviously you can only be no when you're not yes. And then there was an option for other, and that's why this is not all the way to -1. And so what we're looking at here is all of these variables are being correlated against, did you change companies? Yes, right? And so we see the things that are most correlated are people who have previously declined a promotion, people whose partner handles less of the workload, right? People who feel like they were unfairly treated at work as a result of trying to manage, picking up sick kids and stuff, because that happens. And people who find voicing their needs difficult, right? And so this makes, intuitively, we look at this and we're, oh my God, this makes so much sense. Yes, the people who we're changing are people who don't have as much support in the home. Their partner isn't carrying as much of the weight. You could hypothesize that, they're making a change to allow them to more sanely manage their life. They declined a promotion. Again, trying to create that work-life balance that works. So these things totally make sense as to why they would explain or be correlated with people who are changing companies. Okay, so now I will bring this back over so that we can see. Okay, so now we are going to do our splits for the testing and training data. So again, I have my survey data tibble, which was just, how I had called in the data. That was the name I had assigned it to. And I'm assigning this whole thing to a new variable that I'm calling split R sample, because this is where we're using the R sample package. And so this is my function for doing the split. And so basically what I'm doing here is I'm choosing a single variable, and you have to do that because you can't, throw every single variable in the database at it and say, here, give me a random sample. It's, you give it one column and you randomly sample that one and, know where that's indexed. And then later you're able to say, okay, train. So we're putting 80%, we're randomly sampling 80%, and then we're going to create a training set and a testing set. Did I actually run that? I don't know that I actually ran it.
Yeah, sorry, I was there answering some questions. So if you need me for something, I might need to recap.
Yep. Well,
says error in R sample split, could not find function training. So if you just put R sample : training, try that.
does it get masked by something?
It might be. Try running that line.
I didn't read, you know, when you're doing things live, you don't read all of the output that comes when you're loading the packages. Okay, yep, it was masked by that.
Okay.
Thank you.
Yep. No worries. That's why you got a co-pilot, right?
Yeah, okay. And so then we can look at the training tibble that we just created, right? So we partitioned our data and we assigned it to, so we have 265 in our training data. So 80% of this data is in training. And we can take a look at it. And then the other 20% is in this testing data. Okay, guys, now this is where it gets exciting. And well, this probably isn't what you think is the most exciting part, but I think it's very exciting because as somebody who's been doing this for a very long time, I can tell you that I have written hundreds and hundreds of case statements or loops to hot encode my variables, or you know, manually looking at data, doing some exploratory data analysis, realizing that I need to bin my variables, you know, taking a categorical variable and putting a number of the categories into a single category to clean it up. And it's been a very manual process, especially like 8 or 9 years ago. I was writing a ton of code and it was so manual. And if you had a lot of variables, like days of your life was gone to this, right? So now look at this package. This is the recipes package and library. And so basically I'm creating a recipe for my data pre-processing. And I'm saying that the variable of interest is that we changed company, yes. And I'm doing this on my training data, right? So I'm pre-processing my data now. And so we knew that we were going to have to remove the ID variables, right? And we're also going to remove whether or not you changed company to pursue balance, right? Because if it's our response variable, it's not going to be in the rest of the data, and the ID is also not going to be correlated with anything because it's just an index, so we can get rid of that as well, right? So we're doing that in one line. Then we're going to pipe that into, so all of the variables that have near zero variance, right? So if I have a variable where 97% of the variable is all the same thing, or I guess if you had 3%, that still wouldn't be too bad. But basically, if you have all zeros and a single one, like it's probably not going to be useful for my model. And what you're really looking at is maybe an outlier and not necessarily something that's going to help tell the story about, because a lot of times we're, you know, regressing to the mean, right? We want to know what the average person is doing. We want to get an understanding of our whole population, and we're not necessarily looking to detect anomalies. And so with one line, I can go through and remove the variables that have non-zero variance for all my predictors in one line. Really cool, right? Like I didn't need to write a loop and loop through and find out how many of, you know, my variables are sparse. I can just say remove the sparse variables. Anything that is a character variable, change it to a factor, right? So that we can actually aggregate it and group it. And so step string to factor. So here I'm doing that in one line. I'm saying take all my character variables, because you'll see here that these are all, I want them to be factor variables, but they're read in as R by default as character variables. So I'm renaming them to be factor variables. And then this one is also super awesome. If a category in a factor variable is less than 3% of the total population, then just put it in another category rather than having, again, like we did with the near zero variance. We're able to say, and instead of having to, like, do I have code where just to give you guys an idea, you know, previously I'd recode these things by manually typing out exactly what I wanted in, you know, you could imagine that this was other category, right? Like I'm talking about manually typing these things. And in one line, okay, if a specific factor is less than 3% of the total distribution, just group it in another category. Done. One line. I can't see other people's faces, and I assume everyone's not as excited as I am, but it's a big deal.
We're excited because, like, honestly, yeah. And I'm trying to answer all the questions. We're getting so many questions.
Oh, okay.
My fingers are tired. Yeah, like exactly what Kristen was saying. Honestly, the recipes package, this is what I call an 80-20 package. I use it all the time, and it gets me, you know, I'm always using it to do my pre-processing steps, and it speeds up my analysis so much because, like Kristen was saying, it used to have to write loops, and your scripts would be like hundreds and hundreds of lines of code because you're trying to do all of this pre-processing stuff.
And I'd do it in chunks. I'd be like, okay, here I'm going to convert all my character variables to factors. Here's a loop. That's done. Okay, now I'm going to hot encode my character variables, and I'd write something out, and then you know, and so they were all big chunks. You know, one thing to call out here too is that this still doesn't get rid of, and especially since, you know, some data scientists worry that, you know, everything will be automated someday and that we'll be out of a job, right? This doesn't help us with the business context, right? There's still going to be probably missing data in a lot of our data, and a lot of those you need to look at and first say, okay, can I impute this? Is it going to introduce any bias if I just remove it as opposed to trying to impute it? Is it something I can impute? Can this variable just be set to, can this NA be set to 0? You know, there's a lot of those questions that we'll never be able to get rid of, but at the same time, like, this is so fast. And I'm sorry I cut you off, Matt. Did you have more to say?
No, that's great. I went right back to answering some questions, so I'm trying to keep up. I'm
Good.
finding,
I'm glad we can keep you busy.
Yeah, it is keeping me busy.
And so this line is for one hot encoding all of the character variables that we have. So instead of it being male and female, it would be in, you know, a gender variable. Now we're going to have gender male, 1s and 0s, gender female, 1s and 0s. And so it's going to go through and hot encode all of those variables for me in one line, which is pretty similar to feature tools in Python. And then the same thing that we did up here, where we were removing variables with near 0 variance, right? These sparse features. Here we're going to remove these sparse features again after we've gotten the dummies, because we will probably have some pretty sparse dummies. And then we are going to binary variables convert to a factor. All right, so this is saying, okay, this changed company, yes, that should be a factor variable. So we can run this. And that ran. Wonderful. Okay, and then this is where we're getting into the actual parsnip stuff, right? So the bake function actually performs the processing pipeline. So basically I created a recipe here and I named my recipe, and I can reuse that recipe somewhere else. But so I'm going to bake, and so I'm saying actually use this pre-processing pipeline, because that was the name right here. Actually use this pre-processing pipeline on this data and store it in the train pre-processed data tibble, right? And so we'll do that for both the training and testing data. And that's just a warning, it's not an error. Okay, and so then we can take a look at this data. Okay, and see how this looks wildly different than it did before. And that was just from that recipe that did not take a lot of time to write. It was not a lot of steps, but there was like a whole lot of bang for the buck going on there. So I have my gender female. And so if you're, you know, female, then you're not male. And so you can see that now I have a bunch of features that I can use for modeling. And so that's true of both my testing and training sets without doing too much work, right?
Isn't this so cool, guys? I mean, like, seriously, we now have a data set that's ready for machine learning. And what, how many lines of code was that? Like 6 lines of code, 8 lines of code,
something like that. I mean, this used to take me days, days of
now,
writing case statements. If this, then that.
15 minutes now, right?
Yeah. And then, so you guys probably already know, but this is a PSA. We're going to set seed, right? Anytime you ever do analysis and you want it to be reproducible, you have to set a seed so that you never want to get into a case where you build a model, you show your results, and then your stakeholders say, hey, you know what, can you go back and try and force this variable into the model? Or can you, you know, yeah, some new variables come up that might be of interest. Can you try and see if that works in your model? Or can you do some further analysis or whatever? Or if somebody else says, hey, I want to rerun your code, like you have to set a seed, because otherwise they're going to get different results. Especially, we should have also set seed for the sample split as well, because when people go to run this, they will get a different sample split than we got here, because there is no set seed line before this. So I'm just gonna go, just for good practice. Okay, that's just gonna become a part of the code now. All right, so we set our seed, and so this is how we build an XGBoost model, right? So we're creating a boosted tree. This is a classification problem. We're setting mtry to 80. We're gonna do 1,000 trees. And so these are parameters that worked well for this analysis. There is, I do have code, and I could add it here, for the hyperparameter tuning, right? Which is also not that much more difficult. Again, it's, you know, code that sort of looks like this, except it's gonna say, you know, how many trees do you want to try? And you're like, I'll try between 500 trees and 1,500 trees, and it'll go through and it'll iterate. And that actually, we didn't include it here because it takes a while for that code to run, because it's not just building one tree based on these specifications, but it's trying to find the optimal hyperparameters, which means it's basically searching through a grid, right? It's a grid where it's going to try each combination, and then in the end, the one that worked the best, it's going to say, okay, you should use these parameters. Okay, so we are going to pipe that in and then say we're actually using XGBoost. And then we are going to fit the model, right? So this is similar to bake, where we're sort of setting something up, we're like saving a recipe, and then we're going to actually utilize it. Okay, and you can see that that's still running and it just finished. Oh yeah, so I said could show hyperparameter tuning. We did not do that. But we are able to then do predictions. So we built a model, right? And we haven't looked at it yet. But we can see how well it predicts on the test data. And so I had named the model above, model XGB. We're piping that into the predict function, and basically anytime in R, so it doesn't matter whether you're building a logistic regression model or a decision tree or a random forest or whatever, the function to predict is called predict. So we're going to predict the model fit, and the new data is the test data, right? We're not working with the training data anymore because we want to predict for how the model that we built on the training data works on our testing data. We want to get back a probability. And then we can look at that table afterwards and see what is happening here, right? So it's a bummer that these aren't more lined up so that it's easier to see. But basically this person did not change companies, and it was, they had a 59% probability of changing companies. And this person did change companies, and they had a 64% probability or prediction of changing companies, right? Did we have... Okay, so this code was actually down here, but should have been up here. Because this was looking at our XGBoost fit, and it's looking at the feature importance for the features from the XGBoost model that we just built. And so this is actually pretty aligned with what we knew to be true, was that, you know, people who wish they had longer maternity leave, probably more likely to change companies. People whose partner handles less in their relationship is an important feature in whether or not people are going to leave the company. Whether or not the parental leave was fully paid. And so I don't know if that means that those people did or did not receive payment for their leave, but we could look into that. These are people who work fully in the office instead of having the option to work remote, right? And so we can sort of see what makes a difference in terms of the model. And then we see at the bottom that things like, you know, if you're between 45 and 54 years old, it really didn't have anything to do with people leaving their company. And this was other unfairly treated. So the question was, you know, have you ever been unfairly treated as a parent? And it was yes, no, or other. And so these are the people who said other, and there wasn't a lot of them, but enough so that it wasn't removed in the pre-processing step. And we see that that's not important, right? And we could read through all of these. Right, so that is our XGBoost model, and I think that we are, yeah, so I think what happened, predictions test. So I think my code got out of order, but that's okay. Okay, so we might come back to XGBoost. But right now, we are going to look at the classic decision tree. And so that's just the R part function. It's saying that we are going to be doing a CART decision tree. So CART is classification and regression tree. So then you need to specify whether it is classification or regression. And so here we're saying that this is in fact a classification tree. We are saying that changed model yes is the response, and this tilde and dot mean that that relates. So the function is, you know, the response variable is changed company yes, and everything else is fair game for being fit into this model, right? And so we're back to our training data again, because we're going to fit on the training data and then see how it works on the testing data. So I am assigning this decision tree, this R part object, to the name fit. So we'll store that, and then we can, ooh, there's no P there. We can look at it. And so this is really difficult to read. We're going to look at a better visualization of this, but this is basically the output from the decision tree. It says that we have 265 rows. At the root, we are seeing 43% of people left, and you're able to sort of go down and read this, but this is much harder to read than looking at the pretty chart. And so one way that people prune their trees, right, because otherwise it'll just continue to grow and grow and grow, and you could end up with, you know, 1% of your data in a node at the end, or you could end up with 2 observations in there, and of course that's not going to be statistically significant or useful, so we prune our trees, right? And so the metric that we typically use to determine that cutoff is the CP. And so what we'd be looking for here is that with the relative error, we want to see it bottom out and come back. We want to, you know, see it at a minimum, and we don't have that here. So I'm not going to change the CP or rerun this with some extra pruning parameter, but you know, you do have the opportunity to say, and I'm not sure exactly what the code is, but you're able to say like min obs is 50, and that would be saying like, don't give me a node that has any less than 50 in the bottom. Like if you get to a place where you have less than 50, stop splitting, stop growing the tree. Okay, and so, you know, you could prune, fit is where we just saved this, and then saying, okay, well, actually, we're going to implement a different CP and prune this tree a bit. Okay, and so that was named pfit. for pruned fit. And so our part.plot very easily gives us a really nice plot of our decision tree. I wish this was easier to read. I feel like this was easier to read before. Now that I've made it big, I'm gonna rerun it and see what happens. Okay, there we go. And this extra 104 is just a color scheme. So there are, this is actually the amount of data that is given. So you can see that we have, 0 here because the people not leaving the company is actually the highest probability right now, because 56% did not leave and 44% of the company, 44% of people who took the survey have previously changed the company. And we're also told that since this is the root node, it contains 100% of the population here. So then, we see that the most important variable in terms of a split and in terms of deciding whether or not somebody's going to try and change their company in pursuit of better work-life balance is that equal partnership, right? And so we see a lot of similarities between the correlation funnel, between the XG boost, between this model, right? And that's what we typically want to see too in industry, is that some models will predict better and have a higher ROC, but at the end of the day, the story is pretty similar. And that's why a regular decision tree is typically a great tool to run, because this is intuitive and easy to explain to our stakeholders. We can visually show them, hey, the most important factor here was whether or not there was an equal partnership in the home. So for people who their partner handles less and they're saying no, partner handles less equals 0. So it's not that their partner handles. So basically, if your partner handles more or it's an equal partnership, then you go this way. And if your partner actually does handle less, because this is handle less equals 0, so that's handling more, but then it's no. So this is people who handle less. You're the most likely to change jobs. And so here, 67% of these people had changed their company in pursuit of better work-life balance, and it's 19% of this population. And then we can go down the tree and say, okay, your current role is that you're pursuing work. And so we see that 81, we have 81% of the population here before we make this split. This is the next most important variable. And then we're able to see, okay, so current role pursuing work equals 1. And I'd have to look at, because of course we did feature engineering. And so these are the people who are currently pursuing work. And so if you are currently pursuing work equal, and that's yes, then we'd go over here. No, we'd go down here, and we'd see that they are the least likely to switch jobs. And so you'll see here that the gradient gets a little bit, so here we have 80% of people are switching jobs. And this is from people who are from another country. And so you'd have to actually look at the data and how we grouped it and aggregated it and stuff to be able to fully read this out. Here is, do you have no help from family and friends? And that's equal to 0, right? And so the decision tree is something that is incredibly reasonable. incredibly easy to read, but because we had created a ton of binary variables, you do need to pay attention to the context and what's going on to be able to read it well and explain it to your stakeholders. But that's how it's only a couple of lines of code to get the tree, and then you need to go back in your data and say, okay, what is this saying? This is saying equal partnership, partner handle equals less is 0, meaning they actually handle equal or more, but then we're saying that it's no, so it is less. So there is, so this is not the easiest one to read, but it is something where, when you have your own data and it's in front of you and you can look at it and say, okay, yes, no, whatever. But it is one way to say, okay, well, this was the most important factor. This was the second most important factor in making a split. The third most important factor in making a split here was people not wishing that their parental leave was longer, or, it was around people wishing that their parental leave was longer. And then you look at the one and then you say, okay, that's no. And then you need to figure out what that meant. And then based on what that meant, you decide which way you're going down the tree and what it actually said.
And I just want to let you know, Kristen, I just pulled up the correlation funnel. So one thing before I compare the results, so our part is a decision tree. So it's a tree-based model. And the advantage of looking at a tree-based model and also the correlation funnel is the correlation funnel is based on a linear relationship, even though we do the binning and all that sort of fun stuff. So what is interesting with this data set is the first or the most important feature from the correlation funnel is ever declined a promotion. And that is, where's that one at? I think that one's, it's tough to see on the screen.
Right here.
Okay, so that's not the top feature for the decision tree. The second most important feature, though, is equal partnership. Partner handles less. And that's the first most important feature. And then treated unfairly at work. Where's that one at? Is that one?
It's here.
Okay, it's there. And then voicing needs difficult. Where's that one at? So voicing needs, is that one even on there? It might not be on there. It might have been.
No, it doesn't look like it's on here.
Okay, and then there's wish parental leave was longer.
Yeah, that one's all over here.
Okay.
Parental leave longer.
So
parental leave longer.
Yeah, so with the tree-based model, right? So what the tree-based model is detecting is a little bit different, but those top 5 features are predominantly all present in the tree and also in the correlation funnel. So this is good. You've got 2 different types of ways of explaining data and understanding the relationships. And, I think what we'll find too is that, like, if you go to the variable importance for the XGBoost model, that is going to show you which features are super important, because that one does a much more complex algorithm than the decision tree, but it's still a tree-based model. And what you can do is then you can start kind of using the XGBoost model as finding which are the most important features, and then going to the more explainable visualizations and see where they line up. So you can really kind of understand and recognize, hey, all right, XGBoost is saying ever declined a promotion is important. Well, then I go to the correlation funnel. Yes, declined promotion means that they're more likely to change a company. Okay, and then so the feature importance there is wish parental leave was longer. Yes, wish it was longer. And that is on the correlation funnel, I think, number 5. But it is highly correlated. I think it's got a correlation probably around 0.2 or so. So, yeah, it's cool because you can kind of see what the important features are, and then you can start to explain it with these more explainable charts and visualizations.
Matt, would you actually mind? I have to step out for 1 second.
Yeah.
Oh, wait, you don't have the code, do you?
I have some code here. I'm not sure if it's the same code as yours, so I can probably finish her up.
Yeah, do you think so? Is that a
Five,
problem?
yeah, we're on 5 metrics.
Yes.
Yeah, that shouldn't be a problem.
Okay, awesome. So I will stop sharing. I just need to step out for 1 second.
Okay.
Sorry.
Okay. And I'm going to share the screen. Just bear with me for 1 second, guys. Okay. So basically, the code I have is going to be a little bit different because I know she did a lot of the code on her own. She did the decision trees, so I don't have some of that code. But what I do have here is the machine learning model, and then the metrics component. So one of the things with machine learning models are, so if I run this machine learning model, and this is going to run that XGBoost, and then we're going to create some predictions, which is what this section of code does here. So if I have a model and then I've got some training and test set, so I'm going to run my predictions on my test set. I've got some predictions now, which looks like this, where I've got a prediction of class 0, prediction of class 1. So again, what we're trying to predict is whether or not that employee has changed company. So the value is 1 here, the value is 1 here, the value is 0 here. And this one, it's saying that the prediction is highly probable that they don't change the company, meaning they stick with the company, and pretty low probability. So it got this one wrong. But for this next one, it's saying that they're 66% likely to leave the company, and they did end up leaving that company. So what we want to do is we want to then get into some metrics and kind of understand globally, how's this machine learning model doing? Does it have some predictive accuracy? If I have many models, how do they all stack up and how do they compare against each other? And to do that, what we do is we use this thing called the ROC curve. And what we do is we compute the AUC, which stands for area under the curve. So this function here comes from the yardstick package. And what I'm doing is I'm taking this data set, which is my predictions test set, and then I'm going to pass it into this ROC AUC, and I'm going to tell it to take this change company yes and compare that with the dot prediction 0. And what it'll do is it will calculate an AUC for me. And our AUC is 0.637, which I thought I had a higher AUC than that. Thought I was getting around 0.7, but anyways, and then it's got another function where you can actually plot the ROC curve, and this is a nice way if you're comparing multiple models. You can calculate the ROC curve, which gives us a couple different columns: threshold, specificity, and sensitivity. And then so that's a data frame, and then we can use ggplot to be able to plot the ROC, which is 1 minus specificity. So 1 minus specificity, and that's going to be on our x-axis, and the y-axis is going to be sensitivity, this column here. So when we do that, and if I run this little bit of code here, if all works well, should get an ROC curve. So this one particularly, so if you draw a line from 0 to 0 and have a straight line, that's essentially random guessing. So we do have a predictive model. However, it's only given me 0.637. I thought I had a better predictive accuracy. But at any rate, it's at least giving us some
Probably a seed issue.
Yeah, probably was a seed issue. If I ran it a bunch of times, it would probably improve.
Yeah, we could data snoop, find one that works, and then be like, look at how good this model is.
Yeah. Which you don't want to do that. That's a no-no.
Yeah, that's a no-no.
That's pretty much it. So we've kind of gone through the full end-to-end where we're now predicting on some new data, which we did not incorporate into our model. So as we would collect new data, we could then predict whether or not that person is likely to leave. So if we leave that question off of the survey, based on their other questions and how they answer them, we can have some predictive value of determining whether or not they're at risk of leaving a job. So that's the gist of it. Okay.
Yeah, and thank you so much, Matt, for
Do you want me to
Finishing it
continue?
off for me.
Yeah, I might as well, right?
I apologize.
No, 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 no. Yeah, no problem. Stuff comes up. So that's, I think from now, what you guys are seeing, you got a taste of machine learning, which is really good. Hopefully you're seeing the power, because it's super powerful. At the beginning of the presentation, I showed you a couple of common ways that companies are using it to save lots of money. Now what I want to focus on is more of the strategies and tips and how to really learn this, these tools. And I did see, I saw some people asking questions, how do I learn this? This is great. I'm excited about doing all this stuff, but it's a lot to handle, especially if you're new. So here's some secret tactics. Here's some pro tips. The number one thing I see when students are first learning machine learning is they're getting frustrated because, they want to do this machine learning model. They're trying to make predictions, but they end up failing. And it's because they don't have the data wrangling, the pre-processing, the visualization, the ability to really be able to manipulate that data and get it into the right format for your machine learning. So if I can say one thing, and if I can give you guys one tip, it's going to be learn these foundational skills while you're learning machine learning. They're so important. So if you can't do and this is that chart from the beginning, if you can't do step 1 and step 2, you're not going to be able to do step 3, right? So, and I know we all want to do this because it's going to be like when I was actually working for companies, both as an employee and then consulting, the company that, I was building these predictive models, and I was getting a ton of value, and I was able to, drastically increase the revenue that my company was making for the part of the company that I oversaw. And how I was doing it was I was having all of the people that worked with me enter information into a database, and that made it structured. So they would enter information about, which quotes we were winning, which quotes we were losing. And I used to sell these big technical contracts. And what we would do is I would compare the wins to the losses, and then I would run regressions on them. And this was before XGBoost and all that fun stuff that we went through in this lesson. So if you want to be able to run those advanced models and save your company a ton of money, you got to learn these steps first. So my tactic was to get people to enter data into a database, which forced them to structure out their, what is the name of the company? What is the value of the quote? What is this? What is that? And all the different features that I knew had predictive insights in them. And then what I would do is I have R, which I was able to then process the data. Now I never had recipes, so I had to do the loops and stuff, and it was kind of a mess. But now we have a lot of advanced tools, and truly it's a lot easier to learn. So here's how to learn it. I have a course system that I've developed. It's very strategic. It's very problem focused. And what I do is I show you how to integrate tools to, like the ones that we learned today, dplyr, ggplot2, recipes. So these two, for example, are covered in the 101 course, and that's the foundational course. Recipes is covered in the 201 course. Parsnip is covered in the 101 course, and H2O and Lime are covered in the 201 course, which is the more advanced course that teaches pre-processing and automated machine learning and those sorts of things. So the code that we saw today, now we didn't see this. This was in Kristen. This was in your other blog article where you showed how to manipulate the data, right? So this is all dplyr code. And this is the #1 package you need to learn. If you're going to do any sort of machine learning, you need to be able to manipulate data, dplyr. I teach that at length through 3 weeks of the 7-week course, and the 101 are dedicated right to dplyr. The 4th week in 101 is dedicated towards ggplot2, because if you can't explain your model to decision makers, meaning you can't build the correlation funnels, you can't build the R-part decision tree models, and if you can't just take data and put it into a plot that summarizes what you're trying to say, you're not going to be very effective as a data scientist. And I hate to say that, but that's the truth. You can be as advanced with machine learning as you want, but if you can't visualize and explain things and communicate the results, it's not going to help. So that's in the 101. Recipes, this whole string of code here where we did that pre-processing pipeline, I teach at length in the 201 course. I have a whole week that's dedicated towards it, and you learn all of these steps and more, like Yeo-Johnson transformations, like just all sorts of different steps that you're going to run into very commonly. And what this does is, as Kristen and I were saying at the beginning of this lesson, this used to take hours and hours and hours, and now it takes 15 minutes maybe. And the nice thing about it is it streamlines and makes us way more productive than we were ever before. But you have to know how to use it. And if you don't put the steps in the right order, you're going to get bad results. So you need to learn recipes. It's an 80-20 package. I teach it in the 201 course. Parsnip, I teach this in the 101 course. And really what I love about Parsnip is it interfaces with all of these different algorithms. So from a teacher's standpoint and from a student standpoint, you get to experience working with XGBoost, tree-based models, random forest models in the 101 course, decision trees. And then you also get to experience the other 80-20 modeling tools, which are the elastic net, which is the penalized regression. So it combines what is it? It's what they call regularized regression. It basically includes penalties to prevent your models from including highly correlated features and features that don't add value to the model. And then we do support vector machines. So you get exposure to all of these different, what I call 80-20 modeling algorithms or machine learning algorithms. And that's so important because when you get into automated machine learning, which is what I teach in the 201 course, you need to know the strengths and weaknesses of the algorithms, and you need to be able to understand what's going on underneath the hood when you start to get into automated machine learning. Automated machine learning is one of the most important things that I use as a consultant because it totally takes that modeling time from days down to minutes, and it saves me a ton of time. And if anyone knows, when you're given a project and you only have a couple of days to complete it, it may seem unrealistic. So using tools like H2O's automatic machine learning modeling algorithm to get 50 models, not just one, but 50 models. So think how long it would take you to create 50 models, probably a whole week. Automatic machine learning with H2O, you do it in maybe 15 minutes. Lime, we haven't seen Lime. That's another advanced tool. It's for we saw some global explanation, like correlation funnel explains globally the features, but oftentimes what we really are concerned about is why is that specific customer going to leave the company, or why is that specific employee going to leave the company, and coming up with preventative strategies. You use Lime to do that. So that's another 80-20 tool. I teach all of this and more in Business Science University, and I really want to help transform you as a data scientist and teach you the tools that are going to help you succeed and then go beyond just machine learning, which I'll teach you the most advanced machine learning, H2O, Parsnip, Lime, all of the cool cutting edge techniques that get results. None of the fluff that doesn't get results that people like to talk about, but I'll teach you the stuff that actually gets results. And on top of that, I'll make you an expert data scientist by focusing on the fundamentals and teaching you how to work with time series, how to work with text, how to work with categorical data, how to do pre-processing, all of the things that you're going to need to do fundamentally before you get to machine learning. So I'll give you all of that in one condensed package. Here's how it works. What I'm going to focus on is the R track. The Learning Labs Pro is for intermediate to advanced, so I'm not going to really focus on that. But that is something, great that we do have. It's a new course once every 2 weeks that I hold live. You can attend it live or you can get the recordings. But what I'm going to focus on is this R track. And this is based on what I did as a consultant and what I used to do within my last organization that I worked for a few years back. I was developing actual applications and visualizations and reports using machine learning. So what I do is I teach you the way that I learned, which was sort of based on coursework, but it's more based on business problems and figuring out how to solve them. and integrate the tools into that problem solving approach. So it's completely different than any other program that's out there that I'm aware of. Is what I do is I start off with a problem, which is what you're going to be faced with in your organizations, and then you're going to have to figure out how to solve it. And then I show you how to integrate all the different packages. And Kristen's taken the courses. She knows how I work. It's basically one video after the next. We're learning specific tools strategically to not, waste your time, but focus on the most critical pieces that get you up this hill. So you start at the bottom, doing data cleaning, doing a little bit of manipulation. You work your way up to visualization. You then learn functional programming and modeling. You then learn advanced machine learning, H2O, parsnip, lime, recipes, and some of the other packages. And then eventually we get to the next step, which is communicating your results. How are you going to take your data science and get that in front of the decision makers and the people that are actually able to make changes in their processes to produce financial results for the organization. So it's all about ROI, return on investment, and the way to do that is you build web applications. And it sounds crazy, right? If you've never done it before, but it's actually really easy to do with R, to go from the machine learning analysis to building production-ready web apps, and that's what I teach you in my second course. So the little bit more specifics about the program, it's a 3-course system. I am working on a 4th course, and it's coming soon. It's the Expert Web Apps, but it starts off with the 101 course, and you take this, you gain all of your foundations, and then you move to the 201 course, which teaches you machine learning and business consulting. So all of the advanced techniques, all of the pre-processing techniques, and even ROI and optimization, and how do you go from data science to decision science, which is being able to optimize your models based on a financial benefit to the organization. So that's what we call decision science, and it integrates that into the back half of the course. And then you have the Shiny Web Apps course, which is great for learning how to build apps that distribute your data science models. So that way people in your organization can just pull up the app. They don't have to worry about XGBoost running behind the scenes. They just see that you're producing a sales forecast, and this is what the numbers look like, so they can make different decisions on how to, which customers to focus on, which are at risk of leaving, which manufacturing line should I put product on, that sort of thing. That's what you learn how to do with this course. Okay. So a little bit more, if you want to know the details about what's inside, you do get the 101 course is just jam-packed full of content. Weeks 1 through 5 has 25 hours of video alone, where you do data manipulation, time series, text, categorical, visualization, and then even some programming and iteration with the PER library. And there's 3 challenges within those first 5 weeks. Then week 6, which students absolutely love, is 8 hours of video, 3 hours on clustering, 5 hours on regression, and 2 challenges to lock in your learning. And then week 7, you complete 2 projects where you have a product pricing algorithm that you actually predict the product prices based on an existing portfolio of products. So the company's trying to develop new products and figuring out how to price them. And then the second one is a customer segmentation model. So you're going to use a clustering algorithm and also a dimensionality reduction algorithm in that one. The 201, this one's all about business consulting and advanced machine learning. So if you're interested in those 2 things, this course is for you. And you don't have to be a consultant to take it. Honestly, you will learn so much, even if you're not a consultant, because it teaches you how to communicate data science and how to optimize models for what the business cares about, which is financial results. Doesn't matter that you're getting a 0.9 AUC. The organization could care less about that if they don't know how much money is your model going to save them. Yeah. And when you show them those dollars, like I think in this course, the 201 course, you show them that you're going to save them like $3 million a year or $5 million a year based on just making a few different tweaks to how you it's an employee attrition problem. So employees are leaving. So it ends up being stock options and something else over time. And if you can adjust those, you're going to save the company like $3 to $5 million a year. So when the company sees that, they're going to be pretty impressed with you. And in fact, that's going to fund your data science team. So you can build that model and then work on whatever the heck you want, because every year you're going to be saving that company $3 million, and they're going to be pretty happy about that. So that's in this course. Again, you're working way up the hill. You follow a systematic framework that I used to actually follow when I was doing data science consulting. It's called the Business Science Problem Framework, and it's when I implemented that, it was the best communication tool, because everyone saw, even non-technical project stakeholders that know nothing about data science, saw the plan. And they understood, oh, okay, this is why it takes 6 weeks to do a project, because I got to walk through each of these steps. Oh, by the way, this is where this team's involved. This is where this department's involved. This is, we're gonna, this project isn't just dependent on the data science team, but it's also dependent on whether or not they can provide us results and information that's going to help us. So it ends up being a team effort rather than being just me working on a project. So that's what 201 teaches you. And then the 102 course, the third course in the program, teaches you how to build dashboards. And this is not just any ordinary like Tableau dashboard. This is a machine learning powered web app that you can distribute, that your code is totally kept away from consumers, so you can make it client facing. It's also takes away all of the the people using it have no clue that data science is running it. So this is an example of one of this is an example of an app, a sales dashboard, which every company pretty much has. But this is a special dashboard that includes an XGBoost model that predicts daily and weekly and monthly and quarterly forecasts on the fly for specific products, by customer. It doesn't matter. It slices and dices the data for you. And all the user does is that they have drop downs and they pick what they want, and they click the button that runs the model, and their forecast is right there for them. How cool is that?
I didn't realize that you can use XGBoost for time series prediction.
You can, if it's a short enough window. Because if you go out, the problem with XGBoost is it doesn't do trend very well. But the nice, you can see here that trend's not like the long-term trend really doesn't play much of a factor in this model. It's actually the shorter term seasonality. So for models that have a lot of short-term seasonality, XGBoost is actually very accurate.
I'll have to play with that.
Yeah. So check that out. So weekly duration, even monthly sometimes, if there's not a whole lot of trend to it. Okay. And then testimonials. So it's, you can listen to me talk about this program all you want, but it doesn't mean much if other people aren't getting results out of it. And this is the type of program that if you take this is going to transform you so much. And these results are just an example of the hundreds of other results and the hundreds of other students have gotten in this program. So
yeah, I mean, and I can personally give a testimonial too, right? Like,
absolutely.
I started learning R in 2004. I hadn't made the move to Tidyverse, and then I decided I was going to make the move to Tidyverse, so I took Matt's course and I learned a ton, and the code is more intuitive in the Tidyverse, and I was also learning about new packages that I hadn't known before. But one thing that I do want to say is the Shiny app that I created about this dashboard, so this is between us, but a company had reached out and I've been interviewing a bit, and I've been showing them my Shiny app in the interview, and it is something that sells people on your ability to do data science. Is like, oh, I have this app, here it is, and you can play with it. That impresses the pants off of people.
Yeah. And I mean, and the app that you built too, like it didn't really take you very long from starting the course to actually creating it, right?
No, I started Matt's course on Sunday evening, and on Wednesday, like, so 2.5 days later, I was demoing the app in front of people.
That's pretty impressive.
Yeah.
So yeah, I mean, this is what I do. This is what I love to do. And I really want to help you. You know, there's nothing better than being able to help a student take their career to the next level, be able to get results. And the feedback that I've gotten, this is the one piece that I will share with you beyond just, getting results for the business. But I'm here getting a lot of feedback that students are struggling figuring out how to apply data science to business. And that's where this program sets itself apart, is that, students typically come to me when they've tried everything else, when they've done, all the other different programs that are out there and nothing seems to be working. And then when they come here and they take the program that's totally flipped on its side, focusing on the problem first and then worrying about integrating, the appropriate packages, it just clicks for them. And what you see is you get results like this. Your program allowed me to cut down 50% of the time to deliver my solutions to clients. And this is a gentleman by the name of Rodrigo Prado. He's a big time data science consultant at a company called Genesis Partners. And actually, I think he just left that company to start his own business. And he's doing really well. He's working with one of the biggest mining companies in the world. And he's helping them solve a huge HR problem for them. Then we have Adam Mitchell. This quote was after just a couple of weeks in the 201 course where he was learning H2O, and he said, I can already apply a lot of the early gains from the course to my current working projects. And then Mohana, he's a data scientist with a company called Cabbage Inc. And he had actually started learning Python and was really having a tough time with it. He started learning it for about a year, and then he decided to take my course. And what it allowed him to do is allowed him to focus instead on the syntax, which is what he was tripping up so much on with learning Python. When he started R with me and with our program, he was able to just kind of focus on the problems, not worry so much about the syntax. The syntax became clear once he started getting a lot of repetitions doing it through the program. So it just gets results. Here's the special promotion, and we're going to offer this for the next 2 days. It's going to be available 20% off. We're going to give a promotional discount for the R-Track 3-course bundle. That gets you the 101 course, the 201 course, and the 102 course. So Foundations, Advanced Machine Learning and Business Consulting, and gets you the Shiny Web App course for distributing your data science. So
I just shared the link again in the chat.
Okay, perfect. And this is going to be what takes you to the next level, guys. I mean, honestly, if you start taking the program, you commit to it, and you do the data science, there's no way you can fail. In fact, there's one other thing I'll share with you. This is what I'll share with you. So there's a chat. There's this thing called the BSU DS4B, which is Data Science for Business R-Track, and we have hundreds of data scientists in here, tons of them. In fact, we have even more than that. I think that's just the one channel. So basically, this is your communication link to me so you can get questions answered. So because what ends up happening is you're going to go through, and this is normal, you're going to have questions. And what happens is when people get frustrated, that's when they quit. And that's what I want to prevent. So that's what we give you the Slack channel for. So you can communicate with me and 400, 500, 600 other students that are in the Slack channel that are willing to help you. And they also want to see you succeed because they're the same as you, all starting, wanting to learn data science and want to advance their careers. Okay. So that is the deal. And that's the offer that we have for you today. And this is a special opportunity. I really want to help you guys out. All you need to do is sign up for the courses. There's a few different payment options. You can do a single payment, 3 monthly payments, 6 monthly payments, and even 12 monthly payments, depending on how quickly you want to get it paid off versus, you know, your monthly budget. So that's what I wanted to share with you. And Kristen, do you have anything else that you want to add on top of that today?
No, I just want to remind everyone that so you can expect an email from me where I'll be sharing the code and the data so that you can run this yourself. You know, I hope everyone has installed our studio, but if not, it's easy to download. If you literally just Google R download, it'll take you and you can download R, and then after you do that, you need to download our studio on your machine, and you can use this code and the data set and start playing around and recreate these visualizations yourself. And then even still, you know, save this code for when you need to do these things yourself in business. When you identify an opportunity to make a decision tree, you can go back here and say, okay, what was the code to do a decision tree? Not that you can't look on the internet, but it's nice, you know, that recipe that we set up for pre-processing data, like you can reuse that. And you know, if you have the opportunity to, so David, I was just saying that, you know, I'm going to share the code through email. I have your emails from you signing up for this webinar. And then, yeah, if you have the opportunity to take Matt's courses, it is absolutely worth the investment and will save you a lot of time banging your head against the wall trying to read blog articles and stitch it all together, which is how I learned, and it's frustrating. And you know, it is an investment, but it's an investment that absolutely pays off dividends.
Yeah, and it's real world data science. So you're not learning tools for the sake of learning tools. You're learning how to solve real world problems, the same problems that you're going to face, and you're going to have to adapt too. And this teaches you all of the foundations and all of the cutting edge machine learning that is going to help you understand how to adapt and how to really become efficient and productive as a data scientist. So I'm excited to have you in the course. I can't wait. As you can tell, I love this stuff. Kristen, thanks so much again for having me. And it's always a pleasure. I love teaming up with you.
I'm sure we'll come up with something cool. You know, after I do something else cool in R, we'll need to get together to do this again.
And what did you guys think? Did you have fun today? Did you guys enjoy the discussion? Did you learn something? I hope you did.
That was like 6 questions, though.
I know.
Oh,
I'm sorry. All right. Well, I can't even see the chat since I'm sharing my screen.
Yep, I can read them to you. It was good. Thanks. Definitely. Yes, for sure. Thank you so much.
Good.
Thanks, Kristen and Matt. So thank you so much, guys. I mean, that's like, you know, why we do this too, right? Like I love sharing with the community. I love getting data people back together. I love showing people how they can be more effective in their job and maybe show you some tips and techniques that you haven't seen before. It is all, you know, gives me the good feels. Yep.
And in one way or the other, we're going to help you out. So that's what we like to do. So thank you so much for attending. And yeah.
Yes, David, that's a good point. You know, not that I would like openly say it, but you brought it up. A lot of companies, because I didn't realize this until I was, you know, 7 or 8 years into my career, right, was that often there's professional development budget. And if you come and you say, I'd like to take this course, do we have any professional development budget? A lot of times your boss will say, yeah, that's really relevant to helping you do better at your job. We'll pay for it. You know, and so
a lot of the students are, yeah.
If you're going to talk to your boss, you know, because this sale is only good until Sunday, but if you talk to your boss and that takes you a little while, you know, oh, and I'm on vacation next week, but send me an email and you know, we'll work it out so that you can still get the 20% if that's the case. I hope that's okay, Matt. I just made that up.
That's good. No, that's
Matt's
totally
company,
fine.
and I'm just like, don't worry. If you're gonna talk to your boss, come talk to me, and I'll talk Matt into it for you.
And this is a special discount just for you. We really want to get you in the course. We really want to help all of the Data Moves Me fans, and we just want to be able to help you guys grow. Definitely talk with your companies. I know a ton of the students in our course. In fact, we just had one yesterday that signed up. He got it approved through his boss. Actually, he signed up on Sunday. He got it approved last week, and he's in the 101 course this week. So definitely, if you can get it approved.
Throughout my career, I've been able to take advantage of training that is company paid.
It helps them.
I just didn't know that I could ask my boss about it until I was years into my career. Like, oh, wait a second, they have professional development budget set aside, and I can ask for what I'd like it put towards. Like that took me a couple years in industry before I realized it's kind of the norm.
Yeah, and with the speed at which technology is changing for data science, companies need to be making that investment in their employees, because if they're not, the data scientists are they're not going to be learning at the same rate that other companies that do invest in their employees.
You know what? And on what you just said right there, these are the newest packages and libraries that have come out, right? Like if you take a different course or a MOOC online, it's great. You're learning R. If it was made a while ago, it's probably not the latest and greatest and easiest.
Yep. Yeah. And these are the same tools that I use when I consult, and they got a lot of good results for my clients. So they're high impact. They work. They're new. They're cutting edge. H2O. They've been around for a few years, but it's still one of the most advanced algorithms out there that's open source. Yeah, it's all the newest stuff. You're getting it. All right. Well, if there's anything else.
Pixar is horrendous. Learn how to be tidy with Matt.
Yeah, I'm a very opinionated coder, and I do use a lot of the tidyverse. So when I find something I like, I use it almost all the time.
Yeah, base R isn't horrendous to me just because I grew up on it. These packages didn't exist when I started R coding, but now that they're available, it's time to up level.
Well, and it's good for the newer. Yeah, it's good for people that are just starting out that want to learn it as fast as possible. So I'm a big productivity person. If you follow me on LinkedIn, I'm always posting about like, hey, these are what are my habits? What are my, what do I do to get results? I'm big on not wasting time, on learning, the things that are going to get you results as fast as possible. So it's what this program is designed around.
All right. Awesome. Well, thank you everyone so much for joining us today. I hope you enjoyed the code. I hope you think that the problem was interesting. It honestly wasn't that we set out to do it this way. It was, I collected this data, and then it was, what can we do with it? But I'd certainly love to do something like this again with other techniques and algorithms. All right. Matt, do you have any final words?
No, I think I'm good. Thanks for having me, and I really appreciate the opportunity, Kristen.
Yeah, thank you for coming, Matt. You're the best. And
thank you.
I hope everyone has a great week, and we'll see you soon. Take care.
All right. See you guys. Bye-bye.
Bye.